So what actually is a vector? Imagine a massive invisible 3D map. On this map, we draw words instead of cities. Words with similar meanings are placed next to each other. For example, cat and a kitten are neighbors. Car and a truck are entirely different neighborhoods. When you feed a text into AI, it assigns that text a coordinate on this map. That coordinate, which is just a long list of numbers, is a vector. The biggest benefit here is context. If you search for apple, a traditional database just looks for the letters A, P, P, L, E. But a vector system looks at the surrounding numbers on the map. It knows if you means the fruit you eat or the phone in your pocket. Okay, so we have our numbers. Why can't we just save these coordinates in a normal Excel sheet or a standard SQL database? Here's the problem. These vectors aren't just simple X and Y coordinates. They often have hundreds or thousands of dimensions. A vector store is a specialized database built specifically to handle this massive math. Instead of checking every single item, it groups similar vectors into clusters. Vector storage feels like magic, but it isn't perfect for everything. Let's say you are building an app for software engineers, and someone searches for a specific error code. You don't want the AI returning something slightly similar, you want the exact keyword. Vector search is for meaning, keyword search is for precision. The best apps today actually combine both, which is exactly why a tool like OpenSearch is so popular. It can do both keyword and vector search at the same time. Let's jump into the code. We're going to use Python and OpenSearch to build this out. Step 1. We need to bring in our tools. We just type a few lines to import LangChain, which handles the heavy lifting, our embedding model to do the math, and the OpenSearch vector search library. Next, let's create some dummy data. We'll write 3 simple sentences about the movies and save them in a list. Now comes the magic. We are going to take these English sentences, convert them into numbers using our embedding model, and save them into our OpenSearch index. It takes just one block of code to tell OpenSearch where our local server is running, pass it our movies and embedder, and save it to an index called movie index. That's it. The database is live. Now let's act like a user. I'll create a search for the phrase interstellar travel. When we run this similarity search, our OpenSearch measures the distance between our search phrase and the 3 movies we saved. And look at the output. It perfectly returns a guy travels through space to save Earth. It understood the concept without needing the exact words. Congratulations, you just built a semantic search engine. That exact logic is the foundation of how chatbots read your private PDFs and how apps give you personalized recommendation at scale. If you enjoyed this video, make sure to like and subscribe. And comment down below what you want to see next.